6.4. This is what 6.4 is dealing with, except we're going to focus just today on properties of exponents. You must have all questions written down in your notebook for your homework, which is writing down the notes. You must have all of them if you want any points. There's no partial credit here. Let's get going. So here are all the properties of exponents. If you want to, you can pause the video and write them down. I'm going to go over the properties as if they were numbers. So let's say this first property. If I had x to the third times x squared, let's say, you're going to be adding the exponents. When it's multiplying in between, you add them. So this would be actually be x to the fifth. A property when we have it multiplying together. So here we're multiplying 2 with the x's. Here we have a power to a power. So this would be x cubed to the second. Now, even though they're same numbers, they're different in between them. Here I'm multiplying with just in between the x's. This is a power to a power. Power to a power, you multiply the two exponents and you get x to the sixth. See how those are different. Make sure to put a star by these two because that's a spot where a lot of people get confused. If I have more than one thing inside the parentheses, let's say if I have a 2x squared y to the third, now that's raised to the second power. You have to make sure to give it to everyone on the inside. Don't be greedy. So it has to go to the 2, it has to go to the x, and it has to go to the 3. Now if something does not have an exponent currently, that's like having a 1 there. So in this case, this would be 2 squared. Here I'd have to multiply, so 2 times 2 would give me 4. Here I have to multiply, so this would give me 6. So those are 3 of the properties. Now let's go to some more. Oh yeah. So first, if I have a negative exponent, let's say if I have x to the negative second, I would rewrite that so it's like a fraction. This is going to be the same thing as 1 over x squared. If I had an exponent where it was x to the negative third over y to the negative second. Both of these have to switch so that they're positive exponents. To do that, if it's negative on top, it has to move on bottom. So this would be x to the third on bottom. If it's negative on bottom, it has to move to the top. So this would be y squared on top. So that's that property. And if I'm going to be having division between the two, let's say I have x to the third, that's a 3, over x squared. I subtract the exponents. Or another way that I think of this is which one has more x's? Are there more x's on top or bottom? In this case, there's more x's on top. So my x is going to remain on top. And then I subtract my two exponents. So that would just give me x to the first. Now if you focus down on here, what if I had a problem like this? So when I look at this, I have to think, where do I have more x's, on bottom or top? I have more x's on bottom, so I'm going to write my x on bottom. And I still subtract the 2, so this would give me x squared on bottom. See how I write the 1 on top? Because it has to be symbolized as the x's are on bottom. And my last property, kind of like this one right to the left of it, if I have an x squared over y cubed, and this whole thing is being squared, like I said, don't be greedy. Give it to everyone on the inside. This squared has to go on top and on bottom. So this would be equal to x to the fourth, because 2 times 2 is 4, over, if I go 3 times 2 would give me 6. Now one thing that I want to have you see here is this first, right here, property with this property over on the right-hand side. When I'm multiplying, I'm adding. When I'm dividing, I'm subtracting. So a lot of times you think of multiplying and adding to go because they both are positive things. Dividing and subtraction kind of go together. So that's how you should be pairing them up. So in this first problem, if I wanted to simplify this, it's multiplying in between here. So that means I'm going to be adding my exponents. But as you can see, I have 2 numbers out in front. I can multiply those together. I could write this so that the things that are the same are by each other. You do not have to do this. So in this case, 4 times 6 is going to give me 24. And when I am multiplying with the same base, I'm adding my exponents, so this would be x to the 10th. And this would be my final answer. In this problem, I'm going to combine like terms. So here's my x's, those would have to be combined, and here's my y's, those have to be combined. Now this 2 out in front, that doesn't have a partner, so I'm just going to write that 2 right out in front right away. And then I'm going to combine my x's. If you see here, they're being multiplied, so I'm going to add my exponents. So I would have x to the third times x to the negative 2, which is equal to x to the 3 plus negative 2. So that's just going to give me a positive 1. If you write just x, that's fine, or if you write x to the first, I'm okay with that. And when I look at my y's here, I would have y to the fourth times y, which is the same thing as y to the fourth plus 1. Remember, if there's no number exponents, it's always going to be a 1 there. So this would be y to the fifth. So we can write it like this, or just like this. Both these answers would be a-okay with me. Here I have a power problem. That means you have to give it to everyone on the inside. So you have to give it to all the numbers, including the 3. So if you write this out, you have 3 squared. Power to a power, you're going to multiply. So that would be x to the 8th, because 4 times 2, and 5 times 2 is 10. You can leave it like this, or you could write it as 9x to the 8th, y to the 10th. This one's a little bit more tricky. So first I'm going to distribute my power. I'm going to give it to everyone on the inside. So this gives me 2 to the negative 3. Right here when I have negative 3 times negative 2, that's going to give me a positive 6. And then I have y to the negative 3, that would give me negative 9. I do not want any negative exponents. So how I'm going to rewrite this is only when the exponent is negative. Only when the exponent. I'm going to write x to the 6th still on top because that is positive, so it would stay on top. 2 to the negative 3, I don't want that negative exponent, so I'm going to write 2 to the 3rd on bottom. Y to the negative 9th, I don't want that negative, so I'm going to write y to the 9th on bottom. You also could have written it like this. You can actually do 2 cubed, and that either one of those two answers I would accept. Now I have my division problem, so I think, okay, where do I have more x's, on top or bottom? I have more x's on top, so I'm going to write my x on top. That would be like over 1, and I divide, or I subtract the 2. 5 minus 3 is going to give me 2. So this as my answer, or just x squared as my answer. I'd accept either or. Where do I have more x's? I have more x's on bottom. So I'm going to put the x on bottom, the 1 on top this time, and I subtract the 2. 9 minus 2 is going to give me 7. This is the only way that you could write that answer. I know what you're thinking. I can't do this. This is too hard. You have to take it one step at a time. Now when you're simplifying this, I'm going to right away rewrite this so that I don't have this negative exponent. So I'm going to have the 3 still on top, the y to the 4th on top, 27. Here I have x to the cubed that moves down below. I also have an x to the cube that was already down there, and y to the 6th. Now I'm going to simplify this step by step. I'm going to write my fraction bar first. When I write this fraction bar, I can simplify just my numbers together because 3 goes into 27 9 times. So I'm going to write 1 on the top, 9 on the bottom. You don't have to write the 1, but you can if you so wish. When I look at my x's, they're only on bottom, so I know my x has to remain on bottom. And these x are being multiplied together. If they're being multiplied, I have to add my exponent. So 3 plus 3 would give me 6. And then I have these y's over here. When I look, okay, do I have more y's on top or bottom? I have more y's on bottom, so I'm going to keep my y on bottom. And then I subtract the 2. 6 minus 4 would give me 2. So this right here would be my final answer. You must have the 1 on top because this is a fraction. Here again, the first step that you should do is rewrite it so you don't have any negative exponents. So I'm going to rewrite this. This y to the 3rd, negative 3 goes on bottom, so I'm going to write that on bottom. This y to the negative 2, that's going to go up top, so I'm going to write y squared on top. Just the z to the negative 2 is going to move on the bottom, so I'm going to write z to the 2nd, plus I already have my z to the 5th. Now I simplify this. I can't simplify my 3 and 2 any further, so my 3 is going to remain on top, and my 2 is going to remain on bottom. When I look at my x's, I have more x's on top, so I'm going to keep my x's on top. And 6 minus 3 would just give me 3. When I look at my y's, I have more y's on bottom, so my y's are going to stay on bottom. And 3 minus 2 is 1. You could leave it just as y, or write a 1 right there. And my z's are both on bottom. So I'm going to keep my z's on bottom. And now since they're multiplying together, I'm going to add them together, and that gives me to the 7th. Make sure you have all the problems written down. If you do not have all the problems written down, you will not get any points for this homework assignment. Have a great, grand, wonderful day.